Now we have to discuss about that Baeyer-Viliger oxidation, how to involve in the reaction, what are the reactant, then what is the final product. So in this Baeyer-Viliger oxidation, first we have to take any ketones, either cyclic or open chain ketone. It is react with per acids, C double bond OOH, per acids. This is we are calling as a per acids converted to ester, that is a C double bond O, or generally we are taking R dash, here R dash. So both are R's are same, so that I am taking R dash. So sometimes here we are taking, this is also different, that is R double dash. Then it form R double dash C double bond O OH, means per acid converted to acid. Here ketones converted to esters. Ketones converted to ester. How it is involving, then which one involving that oxidation? So here, generally, they are asking the question in examination point of view. Generally, they're asking the question here, three oxygens are there. Which oxygen involving insertion reaction? This is actually insertion. Insertion means in between oxygen, addition of one oxygen. Here always terminal. This oxygen involving insertion in between, that is a carbonyl with the alkyl group. So that it is converted to RC double bond O R dash with again R double dash C double bond OH. This one is a final product. So this oxygen, that whatever that we wrote a star carbon, a star oxygen, it is involving insertion. Then it get the ester with the acid. So this is a insertion of oxygen, addition of oxygen. So generally we are calling oxidation. So now I will discuss about that mechanism of this reaction. Here we are taking, that is a C double bond O, then R ketone with a per acid R C. Here we are taking R dash C. Here one more oxygen. So this is oxygen R dash, then C double bond O R double dash. Here that always the carbonyl compounds involving nucleophilic addition reactions. Here the carbon and oxygen, the oxygen is more electronegativity. Here it gets the negative charge, then it gets the positive. Here lone pairs are there. Here also this oxygen also two lone pairs. This oxygen also two lone pairs. So here this oxygen, terminal oxygen, is more reactive than remaining oxygen. So these oxygen lone pairs are donated toward the acyl carbocation type of carbocation. So here these are the lone pairs donated towards the carbon. Then here it forms CO minus, then R dash, then OH plus, then O, then C double bond O R double dash. But any oxygen having positive charge unstable, here loss of H plus, loss of H plus, then here R C O minus, then R dash O, then C double bond O R dash. Now it is involving R double dash, involving rearrangement. In this case, this bonded electron move towards this direction, then oxygen getting the positive charge here, it get the negative charge. This is alkyl group attack to here. This is a R dash negative. So means carbon get the positive. So here carbon get the positive, that is a RC. Whenever it get the positive charge, positive and negative, it form new bond, then OR dash plus then this is R double dash C double bond O minus. So again it is a loss of, we get here that second step loss of H plus ion, that H plus attack to here, then R double dash C double bond OH. So here we get a ester, here we get a acid. So the final product is acid with a ester. Sometimes they are asking a question in examination. Here, sometimes they are asking a question CH3, then C double bond O, then CH2, then CH3. Here, they will give the MCPBA. What is that meaning of MCPBA? Abbreviation of MCPBA, metachloro perbenzoic acid. Metachloro perbenzoic acid. This oxygen involving insertion. So here two carbons are there. Here one carbon. Always insertion of oxygen. More carbon side. More carbon side. So insertion takes place in this case. So that the final product is a C double bond O CH2 CH3. Always more carbon side. Here two carbons are there. Here one carbon is there. For example, cyclic system. Here this one. Again here per acid. So here we are taking paracetic acid. So here insertion takes place. Always here this is a carbon attached to two carbon. Here this carbon only one carbon. Here more carbon side. So that C double bond O, then O, this one. This one. Generally we wrote finally here. This is both are same. Don't confuse. Both are same. This is for convenient. I will write here. But both are same. Here how many carbons are there? 1, 2, 3, 4. Here also same thing. 1, 2, 3, 4 in between oxygen. So and both are same. Okay, always insertion of hydrogen takes place at a more carbon side. We have to check it out whether which left side or right side, how many carbons are there. You can check it out. Always insertion takes place at a more carbon side.